Hello, Mr. Burrell here. We're in Unit 8 talking about some basics on graphing. We've already had a short lesson on intervals and domain and range. We talked about situations like this, where I had either a graph, or I had a table of values, or I had a set of points, and we talked about writing what the domain and range values or intervals would be for those specific cases. So we've covered that a little bit already. We're going to extend our knowledge of intervals and domain and range to a couple other scenarios that we'll see today. So again, by the end of this lesson, as with the last lesson, I want you to be able to write the domain of a function in interval notation and write the range of a function in interval notation. So, if you have my homework assignment, this is a question off of there that I want to kind of help you through. So this is Tara's car travels about 25 miles on 1 gallon of gas. 25 miles to the gallon. Not terrible. She has between 10 and 12 gallons of gas in the tank. Find the reasonable domain and range values. Or in other words, remember, domain is my input values, what I put into a function. Range is my output values, or what I get out of a function. So if you're thinking very logically of this situation, my input values are probably going to be the gas that I put into the car. I put gas into my car, and what I get out of that is a certain number of miles. So my output value here is going to be my miles. So this is a pretty simple, basic explanation of a scenario in the real world that we can use a function to model. So we could think of this situation as a function that has certain input values, a domain, and certain output values, a range. So we ask ourselves, okay, if the input is gas, how much gas do I have in the tank? Well, I don't know exactly, but I know that there is between 10 and 12 gallons. I could have 10.5 gallons, maybe I have 11.5 gallons, maybe I have 11.9 gallons, maybe I have 12 gallons. I don't know, but I know it's between 10 and 12 gallons. So my domain, the possible input values, is between 10 and 12 gallons of gas. So what's the resulting range? The resulting range is the number of miles that I can go. So keep in mind, if I have 10 gallons of gas and I get 25 miles to the gallon, how many miles am I going to be able to go? Well, that's 250. 10 gallons times 25 miles to the gallon is 250 miles. Well, how about if I had 12 gallons of gas? Well, 12 gallons at 25 miles to the gallon, that's going to be 300 miles. So on 10 to 12 gallons of gas that I put into my car, my input, the number of miles that I can possibly get out is between 250 and 300 miles. So there's some examples that you might see like this in the real world where you can use the domain and range of a function to model this real world situation and analyze it like that. So I want to go over that example. Now, before we start continuing to talk about domain and range, I want us to take a minute to practice graphing these transformations. We've talked about transformations already a little bit, so we're going to graph these transformations. F of x equals x squared minus 8. That is a quadratic function. That's a quadratic function. And this minus 8 on the outside means that that's going to affect my up and down movement, which means that this is going to move down 8 places. So this right there approximately is what my graph there would look like. Here I have the square root of x plus 4, that's a root function, and this positive 4 on the inside of the square root means I'm moving to the left 4 spots. So originally my root function would look like this, now it's moving left 4 spots, so it looks something like this, and it keeps going, and it keeps going, and it keeps going. So, and this keeps going and going and going and going. Now what we're going to determine is what the domain and range values are now. Domain and range values for these two functions. I've graphed them. We're familiar with how to find the domain and range of a graph. We've done that already. So on this graph, if I'm going from left to right, pretend I have this long invisible string that I'm passing from left to right over this graph. The domain of this function, going from left to right, I'm always able to touch the graph. So the domain is going to be negative infinity to positive infinity. Everything. Now let's look at the range. Notice that this graph moved down 8 places. So if I'm going bottoms up, going from the bottom to the top, my range starts at -8. Notice how the range corresponds with my up and down vertical shift that I had here in the equation. So my domain is negative infinity to positive infinity. My range is -8 to infinity with a closed closed bracket here. Okay, here in this function, the domain, look, I'm starting here at 1, 2, 3, negative 4, so my domain is negative 4 to infinity. Notice again, the domain is my left to right. Notice in here I had a horizontal or left to right shift of left 4, and now my domain is negative 4 to infinity. You seeing something? You seeing a pattern? So then my range here, if I'm going up, it starts at 0 and goes from 0 to infinity. So all my possible input values are from negative 4 up to infinity. All my possible output values are from 0 up to infinity. Okay. In these problems, I'm going to focus mostly on the domain. So let's look at a couple other examples. These ones are in your notes if you have them from me. This again is a quadratic function, so it's going to look like a U. X squared plus 7, 1, 2, 3, 4, 5, 6, 7. I'm moving up 7, so my function is going to look something like that. What is my domain then going to be? Well, my domain, just like the one I had on the previous slide, is going to be negative infinity to positive infinity. When I have a quadratic function like this, a parabola, it's going to go on forever and ever and ever in both directions and up. So the domain is going to be everything from negative infinity to positive infinity. How about this one? My square root function, this is a root function. It's going to look like this-ish. This negative 7 in here means I'm going to move to the right 1, 2, 3, 4, 5, 6, 7 places. So this is my new root function. Now my domain is everything, with a closed bracket, from 7 to infinity. Because I start at 7 here, and I go all the way this direction. Notice that when I put anything from 7 to infinity in for x in this equation, that makes me have a positive number underneath the square root, which is why that's the domain of this function. I couldn't have a negative number underneath the square root. I can't graph that on here. So in order for this to work, for me to have a valid domain, that's why the domain has to be greater than 7. So the domain in this case is from 7 to infinity. So that's how we'd find the domain of a function like this. Now, I want to give you some of these situations. I have these two functions. We haven't talked about functions like this. We don't have a parent function name for these, and that's okay. We don't need one. But what we're going to talk about is what the domain of these functions would be. Or in other words, what can I put into this function without getting in trouble? All my possible inputs for x into this function. So if you think of fractions, there's usually some rules when we're talking about fractions or when we're talking about dividing. One of the rules you're probably thinking of is I cannot divide by 0. If you've tried dividing in your calculator something divided by 0, it doesn't work. It tells you there's an error. You can't divide by 0. Likewise, in both of these functions, everything's going to be fine unless I divide by 0. So here, if this value down here, x minus 4, is equal to 0, then I'm going to be in deep water. I'm going to be out of luck. So what value, when I put in for x, makes this denominator equal to 0? Well, 4 minus 4 is 0. So I can't have an x value that's 4. Otherwise, I'm going to be dividing by 0. Everything else works, but not 4. So this is how you write the domain. From negative infinity right up to 4, but this parentheses means I don't include 4, and then from 4 up to positive infinity. So it's everything from negative infinity to positive infinity except for this little sliver of a number, which is 4. Let's look at another example. This one right here, remember, if I'm dividing, the big kicker is I cannot divide by 0. So what value can I put in here for x that would make the denominator 0? Well, negative 5 plus 5 is 0. So I can't have negative 5 in my domain. Everything else is fine, but I can't have negative 5. So in interval notation, that's going to look like this. Negative infinity all the way up to negative 5. And from negative 5 all the way up to positive infinity. Notice on both of these, I have two intervals. Two different intervals, so I can say there's this half of the number line that's included in my domain, this half of the number line that's included in the domain, everything except for, in this case, except for negative 5, in this case, except for positive 4. Let's do one more example like this, or a couple more examples. So in this situation, when I have a fraction, the denominator cannot be 0. So I cannot put 6 in for x here. So my domain would be from negative infinity to 6, close parentheses, and then from 6 to positive infinity. Remember, these parentheses means that 6 is not included because I can't include 6, or else it'll make the denominator 0. In this equation right here, again, the denominator can't be 0, so x can't be negative 9. It can be anything else, but it can't be negative 9. So my domain is going to look like negative infinity up to negative 9, and from negative 9 up to positive infinity, kind of separated into 2 sets of parentheses there. So that's how I would write the domain of that function. Okay, and that's all we have. We talked a little bit about the domain and range of some real-world scenarios, and we talked about the domain and a little bit about the range of different types of equations. So I hope now that you're able to write the domain and the range of a whole slew of different kinds of functions in interval notation. Domain and range is the name of the game in this video. I hope that's what you got, and I hope that was helpful, and I hope that you enjoyed it as much as I did.